Assalamu alaikum, viewers. I am Muhammad Ibrahim on the platform of Dimensional Physics students. Today we will discuss chapter number 6 of First Year Physics, Fluid Dynamics, Exercise, Short Questions. तो आइए स्टूडेंट्स स्टार्ट करते हैं. Students, first question 6.1. Explain what do you understand by the term viscosity? The frictional effect between different layers of a flowing fluid is called viscosity. It determines how much force is required to slide one layer of fluid over another layer. For example, substances which do not flow easily have large coefficient of viscosity, like honey and tar. Substances which flow easily, like water and gases, have small coefficient of viscosity. So next student question 6.2. What is meant by drag force? What are the factors upon which drag force acting upon a small sphere of radius r moving down through a liquid depends. So student, first of all, drag force. Any object moving through a fluid experience a retarding force, a force which opposes the motion of object is called drag force. Mathematically, its relation is given by Stokes' law for spherical object moving slowly through fluid. Fd is equal to 6 pi eta Rv, where eta is the coefficient of viscosity, R is the radius of droplet, and V is the terminal velocity. So these are the factors for spherical objects. It depends on the following factors. It depends directly on coefficient of viscosity, nature of fluid. It depends directly on radius of spherical object. It depends directly on velocity of spherical object. Question 6.3. Why fog droplet appears to be suspended in air? Reason, students, the terminal velocity of spherical object moving in a fluid of density rho is given by. So terminal velocity, students, हमारे पास होती है 2 rho g r square divided by 9 eta. It depends upon the radius of spherical object. आप देख रहे हैं कि terminal velocity का direct relation है r square के साथ. So fog droplet are very small in size. Therefore, their terminal velocity is very small and they appear to be suspended in air. Question student 6.4. Explain the difference between laminar flow and turbulent flow. Laminar flow, the regular flow of fluid in which each particle of fluid moves along a smooth path which does not change with time. In laminar flow, streamlines do not cross each other. But in case of turbulent flow, the irregular or unsteady flow of fluid is called turbulent flow. In turbulent flow, the streamlines cross each other. Next question आपके सामने है 6.5. State Bernoulli's relation for a liquid in motion and describe some of its applications. So students, Bernoulli's equation, the sum of pressure, kinetic energy per unit volume and potential energy per unit volume at any point during steady flow of a non-viscous and incompressible fluid or ideal fluid is constant. Mathematically, P plus 1 by 2 rho P square plus rho GH is equal to constant. So applications आप देखें, Bernoulli's equation has very wide applications, some of which are given as measurement of speed of fluids using venturimeter. Next, working principle of chimney of kitchen is based on Bernoulli's equation. Swing of a cricket ball, working of carburetor of a car engine, lift of an aeroplane, measurement of blood pressure using sphygmometer. Students, ये तमाम applications हैं. Next question 6.6. A person is standing near a fast moving train. Is it any danger that he will fall towards it? Yes. He is in danger of falling towards a train as a consequence of Bernoulli's principle. Reasons क्या है स्टूडेंट? देखिए, when a fast-moving train passed by a person standing on platform, the streamlines of air between the person and the trains becomes closed due to high speed. तो स्टूडेंट स्पीड ज़्यादा होगी, अकॉर्डिंग टू बर्नौलीज प्रिंसिपल जहाँ पर स्पीड ज़्यादा होगी वहाँ पर प्रेशर कम होगा, तो प्रेशर becomes low. On the other side of the person, streamlines are further apart due to low speed and pressure is high. A force act on the person from high pressure towards low pressure, he will tend to fall towards the train. Next, students, question 6.7. Identify the correct answer. What do you infer from Bernoulli theorem? Where the speed of fluid is high, the pressure will be low. Where the speed of fluid is high, the pressure is also high. This theorem is valid only for turbulent flow of liquid. So students, अभी हमने previous question में discuss किया where the speed of fluid is high, the pressure will be low by Bernoulli's principle. So first one is the correct by using Bernoulli theorem. Question 6.8. Two robots moving parallel in same direction are pulled towards each other. Explain. बच्चों सेम रीजन जो हमने भी लास्ट प्रीवियस क्वेश्चन में डिस्कस की बर्नौलीज थ्योरम, तो देखें अकॉर्डिंग टू बर्नौलीज थ्योरम वेयर द स्पीड ऑफ फ्लूइड इज हाई द प्रेशर विल बी लो. When two robots are moving parallel to each other, the streamlines of water between them are forced closer due to high speed, and as a result of pressure decreases, the pressure of water on the other sides of boats is high due to low speed of water streamlines. Hence, boats are forced close to each other due to the pressure difference. Next question है 6.9. Explain how the swing is produced in a fast moving cricket ball. So when a bowler bowls the cricket ball, the speed of streamlines of air on one side, shiny side, become high and the pressure decreases. On the other side, rough side, the speed of air is low and the pressure is high. Thus, a force acts on the ball from high pressure towards a low pressure and causes the ball to swing. So students, ये आप देख रहे हैं इस केस में अपर साइड पे अगर स्टूडेंट्स देखा जाए तो एयर फास्टर एयर हमारे पास है, तो देखिए इधर प्रेशर हमारे पास लो है, बट ऑन द बॉटम यू विल सी दैट इधर बच्चों हमारे पास एयर स्लो है, स्लो मूविंग एयर है. इट्स मीन यहाँ पर प्रेशर हाई है बाय यूजिंग बर्नौलीज इक्वेशन. सो हाई से लो प्रेशर लगेगा और इस बॉल में स्विंग प्रोड्यूस होगा. नेक्स्ट स्टूडेंट्स, एक्सप्लेन द वर्किंग ऑफ अ कार्बोरेटर ऑफ अ मोटर कार यूजिंग बाय बर्नौलीज इक्वेशन. तो स्टूडेंट ये आपके पास एक कार्बोरेटर का बेसिक आपके पास सेक्शन है, तो इसमें आप देखें ये एयर के लिए है, इधर से बच्चों हमारे पास फ्यूल आ रहा है. तो देखें the carburetor of a car engine uses a venturi duct to feed the correct mixture of air and petrol to the cylinders. Air is drawn through the duct and along a pipe to the cylinder. A tiny inlet at the side of duct is filled with petrol. The air through the duct moves very fast, creating low pressure in the duct, which draw petrol vapors into the air stream. तो ये बच्चों हमारे पास बर्नौलीज प्रिंसिपल पर वर्क करता है. नेक्स्ट स्टूडेंट्स क्वेश्चन है फॉर विच पोजीशन will the maximum blood pressure in the body have the smallest value. First of all, maximum blood pressure means students systolic pressure. So the maximum blood pressure in the body have the smallest value when the body is lying horizontally. So option C is the correct option. Last student question 6.12. In an orbiting space station, would the blood pressure in major arteries in the leg ever be greater than the blood pressure in major arteries in the neck? Students, blood pressure would be same रीजन क्या है? आप देखें कि in an orbiting space station, blood pressure in major arteries in the leg will be equal to the blood pressure in major arteries of the neck, as the situation of weightlessness exists in orbiting space station. तो वहाँ पर बच्चों स्पेस स्टेशन में वेटलेसनेस की कंडीशन है, तो ब्लड प्रेशर जो है वो सेम रहे. So thanks for watching this video. Please share, like and subscribe my YouTube channel. Stay blessed.